If I'm brand new to technology, why should I care about an AI system that scans code?
Software is the set of instructions that runs phones, banks, hospitals, games, and the tools people use every day. A software vulnerability is a weakness in those instructions. It often starts as a bug, meaning a mistake the programmer did not intend. An exploit is a way someone uses that weakness, which is why a tiny code problem can become a real security risk. Codename MDASH, is Microsoft Security's artificial intelligence AI code scanning system. It reads source code, the human-written instructions behind software, to help experts find deep security bugs.
So this topic starts with the basics, then builds up to what Microsoft says MDASH can actually do. What's the best way to read the topic?
Vulnerabilities explain software, bugs, exploits, patches, and why security matters even when you never write code. Meet M- introduces Microsoft's read-only AI Bug Hunter, meaning it can inspect code without changing it. Bug Hunt follows how Microsoft describes M- turning raw code into a short list of supported bug reports. AI Team shows why Microsoft uses many AI workers checking one another instead of trusting one brilliant model alone. Findings covers what Microsoft says M- found, why evidence matters, and why human security experts still stay in charge.
If I know almost nothing about computers, what is software in the simplest possible terms?
Software is a long list of instructions, like a recipe with exact steps. People write those steps in a programming language, a special precise way to tell a computer what to do. Those written steps are source code, often just called code, which is the recipe before it is cooked. The computer follows the code very literally, step by step. When those steps are running, you experience the finished thing, the app, website, or system you use.
So code is not magic. It is more like a very long, very picky set of directions. Where do things go wrong in that recipe?
A bug is a mistake in the code, the same way a recipe might have the wrong amount of salt. Some bugs are harmless, like a button showing the wrong color. Some bugs make the app crash, meaning it stops working when it should not. A vulnerability is a bug an attacker can abuse, a weakness that lets the software do something unsafe. An attacker is a person or group trying to misuse the software, like someone noticing the recipe accidentally leaves the back door unlocked.
So not every mistake is a security problem, but some mistakes open a door. What does it mean when people say someone exploited a vulnerability?
An exploit is the trick an attacker uses to take advantage of a vulnerability. A remote attack means the attacker does not need to touch your computer. They can try over the internet from far away. The exploit aims at the vulnerability, the weak spot in the software. Remote code execution, RCE, means a faraway attacker can make your computer run their instructions. That is especially serious because running someone else's instructions can hand them control of the machine.
That sounds less like a broken button and more like someone getting the keys. Why are some vulnerabilities so hard for people to find?
Many hard bugs involve memory, the computer's scratch space where a program keeps things while it works. Use after free is when a program throws something away and then tries to use it again, like clearing the table and reaching for a plate that is gone. Buffer overflow is when a program puts more data into a container than it can hold, like overfilling a cup until it spills onto the counter. These are hard because the clue can be spread across many parts of the recipe, not sitting in one obvious line.
So the mistake may only make sense after you follow a long chain of steps. Could a simple checker just scan the recipe and catch these?
Sometimes the important question is how one piece of data travels through the program. It may pass through one file, which is like one page of the recipe. Then it may hit a choice, where the program takes one path in one situation and another path in a different situation. Then it may move into another file far away from where it started. Only after all that does the danger appear, so a checker looking only for familiar surface patterns can miss the deeper problem.
It is like finding one bad instruction hidden across several pages, not one typo in plain sight. Once a vulnerability is found, what is supposed to happen next?
First, the vulnerability is discovered, meaning someone has identified the weak spot. The maker writes a patch, a correction to the software recipe. That patch is shipped as an update, so people can move to the safer fixed version. Publicly tracked vulnerabilities often get a common vulnerabilities and exposures, CVE, identifier, a shared name so everyone means the same problem. Many companies release fixes on a regular schedule. Microsoft's monthly update day is nicknamed Patch Tuesday.
So, updates are not just new features. They can be door repairs. Why should a regular person care about all of this?
Software now sits inside daily life. Phones, banks, hospitals, stores, cars, and the websites people use every day. There is a huge amount of code in the world, like more recipes than any kitchen staff could read carefully. There are far fewer security experts, the skilled people trained to look for these weaknesses. The deepest bugs are also the sneakiest, because the important clue can be spread out and easy to miss. That creates a gap. Lots of code, limited expert eyes, and attackers looking for mistakes. Good security tools help by giving experts extra review power, especially for the winding problems humans can overlook. For everyone else, installing updates matters because updates often carry the patches that close those doors.
If I have never heard of MDASH, what is it in one plain sentence?
Think of software like a very detailed recipe. Source code is the human-written recipe that programmers create before a program is packaged. A vulnerability is a weakness in that recipe that could let something unsafe happen. Codename MDASH is Microsoft's nickname for a tool that looks for those weaknesses, and it is spoken MDASH.
So it is not the dash punctuation that matters, it is the bug hunting tool.
It uses artificial intelligence, AI computer programs that can reason over text and code. The job is to read source code, find possible bugs, and write a clear report about what looks dangerous. The important limit is that people decide what happens next.
I picture one clever chatbot reading code. Is that close?
A better picture is a hospital team. Microsoft calls mDash a multi-model agentic scanning system. Several AI engines and AI workers organized to search code. And the harness is the coordinating system that keeps that work ordered. An agent is a small AI worker given one job and the tools to do it. Microsoft describes mDash as coordinating more than 100 of these specialized agents. Multi-model means it does not depend on one AI brain. A model is an underlying AI engine, and mDash can use several. That lets one part of the system compare or challenge what another part thinks it found.
What kind of bugs is MDASH meant to find?
An ordinary scanner is like a quick spell checker, useful, but often focused on easier patterns. mDash is aimed at deep, complex vulnerabilities, where the danger is hidden across many files and many steps. One example is memory safety, which means a program handles its working memory in a way that could become unsafe. It works on source code, the written recipe, not on compiled programs, the sealed packages made after that recipe is processed. Microsoft says it has pointed mDash at some of its most complicated software, including Windows itself.
This sounds powerful. Can it change things by itself?
The crucial safety rule is read only, meaning mDash is allowed to look at code, but not change it. It reads the code base, which is the collection of code for the software. It writes an explanation of the possible problem and why the system thinks it matters. It can suggest a fix, which is a proposed repair for people to consider. It does not apply fixes, change systems, or act on its own. People review the report and make the real decision.
Who builds MDASH and who actually gets to use it?
mDash was built by a Microsoft team focused on automated code security, meaning software security checks done with help from tools. Microsoft offers it to eligible Microsoft Defender customers. Microsoft Defender is Microsoft's family of security products. It is set up through the Microsoft Defender portal, a website where security teams manage protection. From there, security teams can run mDash scans as part of their managed security work.
When MDASH finds something, what does a person get back?
Think of a mechanic's note after inspecting a car. The useful output is a clear report. The report names the possible bug, because the finding still needs human judgment. It includes evidence, meaning the code clues that led to the concern. It explains why the issue could be dangerous in terms a security team can check. It suggests a fix, a recommended repair that people can accept, change, or reject. A person still reviews the finding before any real action happens.
Give me the main idea to remember.
MDASH is a team of AI helpers, not a single all-knowing assistant. Those helpers are organized by a careful process, so the work is coordinated instead of chaotic. They read source code, the written instructions behind software. They hunt for deep security bugs that simpler checks may miss. They explain what they found in reports that people can review. And the balance stays clear. MDASH advises, while people stay responsible for real decisions.
Is MDASH just artificial intelligence, AI, software that can make human-like judgments, reading code and guessing?
Think of code like a huge stack of recipe cards. MDASH starts with the code going in.
So not one magic answer, but a process?
Exactly. Microsoft calls it a pipeline, like an assembly line: map, search, argue, merge, and prove. What comes out is not a giant pile of guesses. It is a short list of findings, meaning possible problems that have been checked hard. Each finding carries evidence and fix guidance. So a security team knows why it matters and what to do next.
That already sounds less like a fortune teller and more like a careful inspection.
That is the key idea. MDASH is built to make human review smaller, clearer, and more trustworthy.
Before hunting a bug, why does MDASH need a map?
Like a detective learning a neighborhood, MDASH first reads the whole codebase, which means all the code in the project. It learns how the code pieces connect, because a bug often hides in the path between two pieces. It also marks where internet data enters. That data is untrusted input, meaning information the program cannot safely assume is harmless. Then it studies change history, the record of what people changed over time, because recent or complex changes can matter. From that map, MDASH spots risky areas, the places most worth checking closely.
So it does not search everywhere with the same effort.
Right. The map helps it aim attention where trouble is more likely.
Once MDASH knows the neighborhood, who actually looks for bugs?
Specialist auditor agents go to work. An agent is a software helper given a focused job. They fan out to promising areas, like login code, file code, and web code. Each agent brings back candidate findings, which are possible bugs, not proven bugs. A useful candidate includes reasoning and clues, so the next stage can judge it instead of starting from nothing.
So at this stage, MDASH has suspects, not convictions.
Exactly. The finding is interesting but not confirmed.
How does MDASH avoid bothering people with fake alarms?
Each candidate bug is treated like a suspect in court. One side makes the real argument. An attacker can reach the problem and abuse it. The other side argues not real. Maybe the path is blocked, or the program already checks the data. That debate tests reachability, meaning whether the dangerous code can actually be reached in practice. This filters out false positives, which are alarms that look like bugs but are not.
Only the tougher cases move forward.
Yes, the survivors are the leads that held up under argument.
What if several agents find the same bug in different ways?
That happens often. One entry report, one crash report, and one error report can describe the same weakness. Deduplicate, dedupe, means recognizing that those paths point to the same flaw. MDASH collapses them into one item, so the team sees one problem instead of 3 copies. Actionable means clear enough to act on, with one place to focus the fix.
That saves time and avoids confusion.
Exactly. No repeats means people are not asked to fix the same bug again and again.
What does it mean to prove a bug? Is that like showing the door really opens?
Yes. For certain bugs, MDASH creates a test input, which is specific data designed to try the suspected problem. That input is given to the running program, the actual software being tested. If the flaw triggers, MDASH has watched the problem happen instead of only imagining it. That working proof makes the vulnerability, meaning a weakness an attacker could use, much more trustworthy.
Can every bug be proven that way automatically?
No, some cannot be auto-proven, meaning proven by software alone, so they become leads for a human check.
At the end, what does a person actually get?
They get trusted findings. High confidence means the evidence is strong enough to deserve attention. Each finding includes evidence and fixed guidance, so the team can understand both the problem and the likely repair. One delivery is a machine-readable static analysis results interchange format, SARIF file, a standard file other tools can read. The other delivery is a friendly report, written for people to review. Security teams review that report in the Microsoft Defender portal, a website-style place for managing security work.
So the real trick is the discipline around the AI.
Exactly. MDASH is not just asking AI to look at code. It replaces a pile of maybes with a disciplined search.
If artificial intelligence is so smart, why not ask one super smart system to find the bugs?
Artificial intelligence, AI, is software that can do tasks that normally need human thinking. A single AI model is like asking one brilliant inspector to check a whole building alone. Even a brilliant inspector has blind spots. It can sound sure and still miss something important. In code, the instructions that tell software what to do, that can mean missing a real bug, a mistake in software, or raising a false alarm, a warning that looks serious but is not. If the whole security tool depends on that one opinion, the risk piles up in one place.
So the answer is not one smarter brain. It is more like a team meeting.
Yes, Microsoft's approach uses several AI models and more than 100 agents, meaning AI helpers given specific jobs. Broad searchers act like people sweeping every room with a flashlight. They bring in every possible lead, an early clue that might matter. Strict challengers act like careful friends. Their job is to question weak leads and ask, "Are we sure?" Proof builders focus on showing when a bug is real, using evidence rather than confidence. When independent AI helpers disagree, that disagreement becomes a signal to look harder in that spot.
But a team can also create a mess. How does it avoid a pile of guesses?
The key is the harness, the organized system that gives the helpers rules, timing, and places to hand work off. Raw AI guesses start wide. Some are useful. Some are repeats. Some are noise. Duplicates removed means repeated reports get collapsed, so the team does not chase the same issue 5 times. Debate means one helper's idea must survive questions from another helper before it moves on. Proof means evidence a person can check, not just a confident sentence. The result is an evidence-backed finding, a report with reasons attached.
AI changes so fast. Wouldn't this whole setup become old very quickly?
That is why the system is model agnostic, meaning it is not glued to one particular AI engine. Think of a kitchen that can use a better mixer without rebuilding the whole kitchen. The system has a model slot, so an older model can be replaced when a better one arrives. The careful work still carries over, the map of the code, the debate rules, and the proof steps. That matters because the long-term value lies in the organized system, not in whichever model is smartest this month.
Can customers see what the system is using, or is it a sealed box?
Transparency means the customer can see what is being used instead of trusting a sealed black box. Microsoft Foundry is Microsoft's platform for running AI models, like a managed workshop where the models are available. Teams can see model usage, meaning which model is doing how much work. That work is measured in tokens, small chunks of text the AI reads and writes. Seeing tokens helps teams watch cost and behavior, the way a home energy meter helps you notice what is using power.
I would assume disagreement is bad. Doesn't it mean the system is confused?
Disagreement is not failure. It is like 2 smoke alarms reacting differently. It tells you where to inspect. One model may say, "This looks real." Another may say, "Not enough evidence." The system treats that clash as a signal to test harder, rather than picking the loudest voice. That extra testing lowers 2 risks, missing a real bug and wasting time on a false alarm. So teamwork improves judgment, Not because every helper is perfect, but because the helpers catch different mistakes.
So, what should a beginner remember from all of this?
For bug hunting, finding mistakes in software before attackers can use them, one lone genius is a shaky bet. A coordinated team of AI helpers is stronger, because each helper has a narrow job and other helpers can question it. The harness keeps the team organized. Assign roles, run debate, remove repeats, and demand proof. And because better models can be swapped in, today's careful setup can still matter tomorrow. The simple takeaway is this: many careful minds organized well beat one lonely genius.
If I am brand new to this, what is the simple headline? Did Microsoft say this thing really found problems?
mdash is Microsoft's name for an artificial intelligence AI system, meaning software that can do some tasks that usually need human thinking. And here it was used to help hunt security bugs. On May 12, 2026, Microsoft publicly said mdash had helped its researchers find new security problems. The main number was 16 new vulnerabilities, weaknesses in software that someone could use to cause harm. Those problems were in Windows networking, the parts that help computers talk to each other, and sign in, the parts that check who you are. 4 were critical remote code execution, RCE, meaning a faraway attacker might make the computer run their instructions, and critical is the most serious rating. Microsoft says all 16 were fixed in that month's Patch Tuesday update, its regular monthly bundle of security fixes. Each one also received a Common Vulnerabilities and Exposures (CVE) identifier, the public tracking name for a known security hole.
Those sound serious. Were these problems near the surface or deep inside the computer?
Think of a computer like a building. 6 were in user mode, the ordinary space where everyday apps run, like offices people use every day. 10 were in kernel mode, the core, most trusted layer, where the machine's most important work happens. Some touched Windows kernel networking code. The kernel is the core of the operating system, the basic software that runs the computer. Others involved secure links, the parts used when computers try to connect privately and safely. Deep bugs matter, because a problem in a trusted layer can affect the whole machine, not just one small app.
One announcement is useful, but how do we know this approach works beyond one Microsoft example?
Microsoft also points to CyberGym, a public benchmark which is like a standardized exam for bug-finding systems. The exam used 1,507 real-world bug-finding tasks from 188 open-source projects, meaning projects whose code is publicly visible. mdash reached the top published score at the time, about 88%. That was several points ahead of the next entry on the leaderboard. It did this with generally available AI models, not some exotic private kind of machine intelligence. Like a driving test, a benchmark does not cover every road, but a top score is meaningful evidence that the method works.
So it finds things well. But I do not want to imagine it as a magic robot fixing everyone's computers by itself.
First, mdash is read-only. Like a smoke alarm, it can alert and explain, but it does not grab tools and change the house. It works on source code, the human-readable instructions developers write, not on finished packaged programs. Its AI-based answers can vary between runs and can take a while, the way 2 careful reviewers may not use the exact same words. That makes it a strong fit for careful review and a poor fit for instant gates, the automatic yes or no checks that must answer right now. It is not replacement for ordinary security checks or human review. It adds a deeper helper layer on top.
What happens after it finds a problem? Does the machine just change the code?
After mdash finds a problem, the finding is still only a finding, a claim that people need to consider. A developer may choose an optional draft fix, meaning suggested code changes made on a fresh copy, not on the live product. Then comes developer review. A person checks whether the suggestion is correct and safe. Human approval is required before the change becomes part of the real work. Only then does anyone apply fixed decisions. Nothing ships automatically.
For someone who just uses a laptop or phone, why should this feel like a big change?
For most of computing history, deep hidden bugs were like tiny cracks behind a wall. Real, but very hard to see. Finding them often required a rare expert to trace many steps by hand. What is new is an AI team checking one another's work, instead of one tool making one quick guess. They can argue and prove their claims. Prove here means showing the path that makes the bug real. The result can be a clear explanation that a human can inspect. If that happens early, teams may fix before attackers find the same hole.
Give me the one sentence I should remember after all of this.
The simplest takeaway is this. mdash helps hunt the hardest bugs at a scale people could not reach alone. The machine does the exhausting search, like checking every aisle in a huge warehouse without getting tired. But it is not oracle work, not a magic source of certain truth. It still needs human judgment. Humans decide matters of urgency, because not every possible issue deserves the same response. Humans own the fix, meaning people remain responsible for what changes and what ships. Done well, this can mean safer software, problems found earlier, with humans firmly in charge,